Hi, welcome to Jumping into Solutions. Today we're going to be talking about electric water heaters and electric heating systems. I'm here today with Constance Butel, and she has graciously opened her home so we could see her electric water heater. So Constance, can you tell me about how your water heater works?
Okay, well, it's a mini split or a heat pump water heater, and that means that it doesn't just plug into the wall and draw electricity. It actually does plug into the wall, draws electricity, but it does it very, very efficiently. The heat pump system is about thermodynamics. Heat seeks cold, and there's a liquid in here that is under high compression. It's under compression and draws warm air from cold air. And so it gets really cold up here, drawing warm air from the garage. And there's a little benefit in the summertime. It helps cool the garage a little bit.
Oh, that's kind of neat.
Yeah.
You know, for people that can't see the water heater, it surprises me because it looks like a regular water heater, except it's bigger. It seems wider. And why is that?
Well, number one is insulation. So you want to maintain the warmth. That's one thing. Number two, you don't have a stack eliminating any gas because there's no gas lines into it. And it's probably a little larger capacity so that I have more hot water when I need it.
Oh, that's great, because I know you run out of water a lot so easily. Everybody
I
does. We do in a house full of 3 people.
Yeah, exactly.
So you could imagine.
I don't anymore anyway.
So tell me, how is this different than a gas system?
Well, gas maintains a constant heat, so you always have a burner on. You're always heating the water, and on all heaters you set it to a temperature. This is like 120. Most of them are at 120. With this, it maintains its temperature in a really finite, discrete manner, and it's much more efficient in terms of the energy use, and of course less dangerous, no particulates or anything like that.
And the big question everybody always wants to know is, does it save you money? I know, I guess with solar and things like that, it can, so that's my question to you.
Well, again, it's life cycle costing. It's an expensive piece of equipment to begin with, but I would say in about 5 to 6 years I'll start getting a return on my investment, and from there on it's money in the bank. Wow,
that's really good. So another question I have is, why did you decide to switch over?
Okay, good question. It goes to actually preserving the planet and conserving it for the future.
Well, let's take a look at your home heater.
Okay, well, it's several components.
Okay, well, let's go for it.
Okay.
Oh wow, Constance, this is amazing. Can you tell me how this works? I mean, it kind of looks like this, I don't know, a large suitcase. That's all I can say.
My little Fujitsu system. Well, this is just the outside air handler. Okay. And I've asked you to put your hand here.
Oh
and
my.
It's like ice cold.
It is freezing cold.
Well, we are in a very cold winter time, even though it's March. And what this component is doing is drawing, believe it or not, warm air from the outside.
Wow, okay.
How? Because in here it gets really cold, colder than the outside air.
Oh, wow.
And whatever warm air is in, down to I think 30 degrees.
Oh my goodness, wow.
It will, and I don't think it's 30 below, but 30 degrees, it will draw heat from the outside, pulls it in, goes under here, and then it goes up to my attic.
Wow.
Where we have the compressor and the other components of the system.
I see.
This does both air conditioning in the summer and heating in the winter. Okay. It's called a mini split system. Very efficient and very quiet.
I was going to ask you, now, I understand some mini splits will have, ducts put into the wall where the air comes out. Is yours a central, or is it one of the
It's a central one.
Oh, okay.
Those you can do just a room, and if you don't have the space for it, or you're in an apartment or a condominium or something like that, you don't have the landscape, you probably want one of those systems.
So again, the question about why? Why? No, I kind of know the why, which of course is the
cost.
same. Cost, yes.
Cost.
Everybody always wants to know if they're going to save money down the road doing this.
Oh, definitely you will.
Okay.
My average, now I have solar as well, but my average winter time, and remember solar doesn't do much for you in the winter time, a little bit, but my highest bill was $140.
Oh my gosh.
My highest bill for heating in the winter time. But my average is about 30 to 40 winter time.
That is so incredible. This is sad to say. In my little house, which I'm going to say is under 1,000 square feet, we had a $400 bill 2 months ago. $400 for 1,000
Should
square.
put it into.
I am ready. I am so ready, Constance.
Hi, everyone. This is Kathy Carriage, a longtime Benicia resident, and I want to thank Constance and Pat for their little video. Special thanks to Constance for letting us see her systems in her own home. Pat is the co-host here. Pat's a wildlife photographer, and our special guest today is Tom Cabot, who is an energy engineer. He has a lot of experience with the utility and building science. So he's a real expert in this area. So Tom, let's just start off with one question. Can you tell us what the main difference is between a gas water heater and a heat pump system and a home, gas furnace and a heat pump space heater?
Thanks so much for the chance to talk with you guys. So, well, let's start with the water heaters. A gas water heater, many of us are familiar with them. There's lots of them in California. They burn gas right under the tank, and they have a chimney running up through the water heater. And the idea is that the burning gas will give its heat to the tank of hot water, and then you can use it. And then the electric resistance heaters of water heaters of old that you're used to, they're kind of more a sealed tank with 2 electric resistance elements in there, and they're able to heat water, but they just kind of consume the electricity to heat the water. And that's really simple. And whereas a gas water heater might be 60 or 70% efficient with 30% of the heat going out the stack, the electric resistance water heater might be 95% efficient with 5% of the heat just being lost to the room. But these new heat pump water heaters, they're really something, because what they do is they use the sealed tank like the electric resistance, and then they run a backwards refrigerator that Constance, I think, tried to explain also. And so what that's doing is really grabbing heat out of the surrounding air, like grabbing heat out of the ambient air in the garage, jacking that heat up to a high temperature and using it to heat the tank of water. And it can be 300 or 400% efficient, because it could use 1 unit of electric energy to go grab 3 units of thermal energy from the air, raise it to the right temperature, and put all 4 into the tank.
Is that going to be cheaper to operate then than a gas or electric water heater?
Yeah, so it all depends on the rates. And so right now it's way cheaper to run a heat pump water heater than to run an electric resistance water heater. And it's a little bit cheaper than running a gas water heater. So yeah, their economics, their operating costs are competitive with gas water heaters, and a lot better than electric resistance that most people think of when we start telling them we need to electrify.
And then the space heating, the heat, I always want to call it heat cooling pump, because it's also an air conditioner.
Right.
Those operate on the same principles.
Right. They're basically like a refrigerator that's able to reverse itself, but it's either able to grab heat out of the yard in the winter and use it to heat the house, or in the summer, we're all familiar with, grab heat out of that house, say the house is 80 degrees, and shove that heat outside where it's 100.
And are they more efficient to operate?
Definitely. Yeah, same thing again. A gas furnace might be anywhere from 80 to 95% efficient, because all it can do is burn chemical fuel and try to make heat out of that. Whereas the heat pump could grab 3 units of heat from the yard with 1 unit of electricity and put all 4 into the house. So it can be 400% efficient.
Well, so they should be cheaper then. Once you install them, you're going to save money on your electrical bill.
Especially if you run them in the right hours of the day now. So one of the tricks now with PG&E coming up with these time of use rates is to run them more to like pre-cool your home in the summer, and then coast across a few of the expensive hours, and then kick it on again when the rates are back down. That's the way to really save operating costs on these things. Or the other way is also if you want to get solar electric. That's a cheap source of electricity.
Yeah, very cheap. Okay, I know because I've got solar and it's I compare my bills and they are a lot less than other people's. So when you put these in, is your gas source totally eliminated, or do you have to electrify your whole house before you could?
Yeah, so a lot of people have about 4 gas uses in the home. If they've got everything, they've got the space heating, the water heating. Some people have cooking, about half of them, and then about 20 or 25% have gas dryers. So if you've got all 4 and you want to get rid of you turn off the valve to your gas pipe, you need to electrify all 4 things, and so once you've done that, you can turn that off. That's what we've done at our house, and it's nice to have it off. And I got to skip that whole gas price surge thing we just went through in January.
I have a question. A lot of people in apartments, we're talking a lot about home air conditioning and heating. So what kind of systems would a person in an apartment use?
Right. So in an apartment, when you're renting, the landlord's got most of the control over the central equipment and the installed equipment. One thing the apartment dweller can use is what I've got upstairs in my house. It's a window heat pump. So it's like a window air conditioner, but it's got the reversing valve inside it. And so it can heat our house in the winter and cool it in the summer. And so it's portable, so then you can take it with you when you go.
Is that the mini splits that Constant mentioned in her video?
No, so the mini split is installed in a property and becomes permanent there. And whereas the window heat pump is called a packaged unit. So it's all together in one box, just like a window air conditioner is.
Wow. Okay. Well, that's really interesting. I had a question. What are air pollution and greenhouse gas impacts to switching to electric?
Well, this is something that people in the Bay Area are going to be starting to really have to think about, because we now have new regulations where in a few years we are going to, if your water heater breaks down or if your gas furnace breaks down, you're going to need to replace them with something that's non-polluting. I think a lot of people don't realize that our gas appliances pollute the air. They have nitrous oxides that they emit, and those, when they combine with other things, form ozone and particulate matter, especially small particulates. They call them 2.5, PM 2.5. Those little particulates can go right through your lungs into your bloodstream, carrying all kinds of toxic things. So it's not only asthma that's affected, it's also your heart, your respiratory system, and it also creates ozone, as I mentioned. And when you combine ozone and small particulate matter, the health impacts are not good. They're just starting to do research on this, and it particularly seems to affect people with high blood pressure. So they're definitely major, there are health benefits to getting rid of these gas. They're really methane appliances to getting rid of our methane appliances. And the Air District basically thinks that the pollution from these sources probably kills about 85 people a year.
Wow.
There's also a lot of climate benefits, because methane is it's sort of a super polluter. It is a greenhouse gas, but and we're used to talking about carbon dioxide as a greenhouse gas, but there are a lot of different greenhouse gases, and it's 80 times more powerful than carbon dioxide, but it's short-lived. So, its lifespan is not nearly as long. So it's one of the best ways to actually, start getting rid of, start really approaching, reducing our our global warming, because if we can get rid of a lot of methane, it has a pretty immediate effect. And about 25% of today's global warming is caused by methane from human actions. So those are, some real important reasons that the Air District has now approved these regulations, where we will be switching out of these appliances in the, not too far future.
Wow, wow. Well, thank you, Kathy. That's really helpful. Tom, is there a way that we should get ready for this change in terms of fixing our house or converting things over to electricity? Do we need panels and things like that?
Yeah, I'm glad you brought that up too. So it definitely makes sense to start planning for it. As Kathy mentioned, the Air District has implemented its new rules that will phase out the installation, the replacement of gas devices, starting with gas water heaters in 4 years in 2027. And then gas furnaces 2 years later. They just won't be available on the shelves anymore. So your regular repair folks are going to be familiar with them. They'll be going to get what's on the shelf, and they will have been trained in doing it. So, but the way we can get ready for that is to make an electrification plan at the home, which is to take a look at what we're going to need for cooling, heating, cooking, and drying, and picking the efficient appliances that can all fit on the electric panel. What our studies are showing us is that most homes under about 2,800 square feet can electrify on a 100 amp electric panel. A lot of people call that panel small, but if you're using efficient equipment, then you're not overloading the panel. And so there's just a lot of looking at that and right sizing the equipment and picking the efficient ones, which, with our high California utility rates, you really want to pick equipment at the top end of the efficiency stack. In other states, maybe you can pick that bottom end federal standard stuff, but not here. It doesn't make sense.
Tom has done a whole YouTube video on how to plan for these upgrades, and talks extensively about, how you can avoid having to put in a new electrical panel. And we're going to be doing a little short video on that in the future. We'll put a link to his YouTube video that is in the website. It's bluegreenandyou.org, and I would refer everyone to that for much more detailed analysis.
Yeah, so the other question everybody wants to know, Tom, is how much does it cost to put things in? Is there any help for people?
Yeah, are there rebates?
Yeah. Luckily, there are rebates, because we're needing the rebates right now to help the market transition, because the climate problem caught a lot of us who weren't listening by surprise. And so now there's a lot of catching up to do. So rebates are needed to help transform the market and help the contractors get used to the new equipment. They're for water heating, heat pump water heating, they're federal tax credits that anyone who pays taxes can get. And those are 30% of the cost after all other rebates. And that's up to $2,000 on each heat pump water heater. And then even before that, there's a BayREN credit of $1,000 for heat pump water heaters. And then in different people's service territories, depending on who your community choice energy provider is, they may have incentives as well that stack into this. And so you take those first incentives from the community choice aggregator, the Clean Energy Group, and then from BayREN, and then everything left over, you get a 30% tax credit on. And then later this year, maybe early 2024, the state will be rolling out the other side of the Federal Inflation Reduction Act, which has rebates up front for middle income and low income families to further drive down the cost. Another $1,750 on heat pump water heaters, and up to $8,000 on heat pump space heating systems. So
Wow.
there are lots of rebates.
Where do I sign up?
Yeah, yeah, it's there's some impressive assistance out there. And given that if you need cooling, you need a heat pump. That's what an air conditioner is. And then if you get the one called a heat pump that can go both ways, it can heat and cool. It has, very little additional cost to having that little reversing valve inside it. And so it actually, after the incentives, is much cheaper than not having the heat pump and trying to do your cooling with just a plain old one-way old air conditioner. So out with the old and in with the new heat pumps.
Tom, I know when I watched your longer video, you actually showed that for some people, low-income people, it can be virtually free to install a heat pump water heater.
Right. Yeah, that's what we're finding here in San Mateo County, where Peninsula Clean Energy is offering big rebates to start with, and then there's the Bay Ren rebate, and together that with shopping for an installer who's, we've got installers giving all kinds of prices, so you can find really high prices, or you can shop around and work your way down to lower prices. But sometimes the incentives will cover it. And then, next year with the middle and low income upfront incentives coming out, administered by the state from the federal IRA, there'll be even more, and so you can get down to zero cost for low and middle income customers in some territories.
I want to thank you, Tom, very much, and encourage people who are thinking about this to watch his longer, more exhaustive video at bluegreenandyou.org.